Hello, this is Mr. Kusaj. Welcome back to day 2 of chapter 4.4. So what we're talking about is the sine and cosine graph. So if we just have y equals sine x, we know what that looks like. And then previously we talked about what this number is for. This is the amplitude. This tells us how tall, right? How far it's stretched up or squeezed down. And now what we want to talk about is, and the other thing we talked about, of course, was the negative. The negative simply flips it over. Now we want to talk about what these other numbers do. So if you have a number further down the function, what does it do to the graph? First, let's talk about the period. The period is the distance between repeat points. So if you look at a sine wave or a cosine wave, eventually it'll start repeating. So for this one, it starts repeating right here. So we say the period is 2 pi. That's the distance. That's the distance that it takes to repeat. Over here, if you look, right, I changed my scale here. So if you look, it starts repeating right here. We start here and go to here, or here and here. So the question is, how long is that length? How long is that length? It's not 2 pi now. Now it's pi. Okay, so the period is the distance between the repeat points. If you're looking at the function and you just want to know the period, all you have to do is take 2 pi and divide it by the b number. That's the number right in front of x. Okay? So for sine x, that would be like 1x, so it'd be 2 pi over 1, which is 2 pi. So it takes 2 pi for the whole cycle to happen, for it to start repeating. Notice the absolute value, which means we want it always to be positive. You can't have this, the distance can't be negative, so it's always positive. Okay, so here's an example. This is not finished. The example says graph f of x equals cosine x, and then graph g of x equals, that should be an equal sign here, equals cosine x over 3. So notice cosine of x is easy. That's just the parent graph, right? That's going to start here, go down under pi, up on top of 2 pi, right? That's one. And then another one, and then another one. So that would be f of x. Now what does g of x look like? G of x, notice that my b is 1/3, right? So my period is 2 pi over 1/3. Do the math, comes out to 6 pi. So what that's telling me is that I have to fit, right, one wave, right, one complete wave before it starts repeating in 6 pi. In 6 pi. So doesn't that mean that we're going to have this U shape, but it's got to take up not 2 pi like it normally does, but it's got to take up 6 pi, like that. So you can imagine it's going to look like come down to here, go up through here, and then to here, right? Got to be symmetrical. So here we go. This is going to be the center, right? This is going to be the minimum. So I would start here, go through here, come down here, turn, go up, and this is, right, from here to here. That's when it starts repeating. From here to here is 6 pi, because the period is 6 pi. So it's got to start repeating after 6 pi. Okay? Which is a really stretched out graph. Okay. Next, we want to look at the frequency. Frequency is the number of complete cycles in 2 pi. Okay, for example, here, here's 2 pi, and I have 1 complete cycle. So we say the frequency is 1 here. Okay? Here, the frequency is, what do we have? 1 2 cycles. So here in 2 pi, we squeezed in 2 complete cycles, so the frequency is 2. Okay, how do you find the frequency from a function? Well, it's the other way around. B over 2 pi, absolute value of b over 2 pi. Notice that the frequency and the period are reciprocals of each other, which makes sense. Think about it. Here, well, let me show you in an example. Well, I'm going to put them all together in an example. So I'm not going to do this separately. You will see how frequency and period are in fact reciprocals of each other. So before we go to an example that includes both of them, let's talk about phase shift, and then we'll put all 3 of them in one example: the period, the frequency, and the phase shift. Okay. The phase shift is when you take the graph and shift it left or right of the parent graph. So if you look at this example, the dotted one right here, that would be the parent graph. Okay, that's just plain old sine of x. Notice how it shifts over to the right. The solid one here, it shifts over to the right. We call that a phase shift. Okay, by the way, how far to the right is it shifted, right? So if you look at the units here, if this is pi, this must be half pi. So we shifted to the right half pi. Okay, we shifted to the right half pi, pi over 2. We shifted to the right pi over 2. Instead of starting at 0, we started at pi over 2. Right? Everything is shifted over. So how do you find the phase shift? By just looking at the function. It's negative c over absolute value of b. Okay, so let's put all that together in one example. So if I were to give you a function, you should be able to find the amplitude, the period, the frequency, and the phase shift. Okay, so here's your function. Y equals sine of 3x minus pi over 2. So you should be able to know how to use these numbers to get all 4 of these concepts. Okay, first thing you should do, since these numbers represent from the formula at the beginning, remember the formula at the beginning? A, B, C, and D. Well, we don't have D yet. We'll save that for tomorrow. Our A is 1. Our B and our C, right? Our A is 1. Our B is 3. And our C is negative pi over 2. So, the amplitude from yesterday, or from the last notes, was simply A, right? But it's always positive. Right, so how far away are you from the midline? It's 1. The period is 2 pi over b, which is 2 pi over 3. Okay. The frequency is the inverse. So if you remember that, you don't even have to do anything. You just turn this upside down. Right? The frequency is the, I'm sorry, did I say inverse? Reciprocal. It's the reciprocal of the period. Excuse me. And finally, the phase shift. The phase shift is, now here you got to be careful. It's negative c over b. And my c is negative pi over 2. So it's negative, negative. So it becomes positive on top. So my phase shift is pi over 6. Now, this would be, this is all the information you need to graph it. And you could graph it. But to graph it by hand would take a long time just to do this. But what you have to know is to be able to look at any function, right? Look at any function and answer these questions. Plus, you should be able to look at any graph right, any graph and answer questions like what is the period, what is the frequency, what is the amplitude, etc. Okay, as far as physically graphing it by hand, we'll do some simple ones to see the differences of two functions, but we'll never physically graph by hand really complicated ones. Okay, so let me show you one more time all the notes. Here's page 1 on the top, page 2 on the bottom, the very bottom. I'm sorry, not page 2. I'm still on page 1, the very bottom. Here is page 2 on the top, phase shift. No, this is not page 2. I'm sorry. This is page 2. Page 2 was frequency. Notice the reciprocals. And then finally in page 3 we did phase shift, and we put it all together in one problem. How do you find amplitude, period, frequency, and phase shift of one function? Okay, make sure you copy everything, come up with questions, and tomorrow in class, instead of me writing the try problems here, I'll give you some try problems tomorrow in class, and maybe you can work on those while I do some other things like pack. Maybe I shouldn't have said that, because after this year, if I save the video, that won't make any sense. All right, see you tomorrow. 12 minutes, that's not bad. Good night.